Okay, in this problem we're asked to find V0. You can see where V0 is. We have an ideal transformer. So we're going to use our problem solving strategy entitled Circuits Containing Ideal Transformers. And if we look, one of the first things it says is look at the circuit diagram, determine the assigned voltage, polarities, and current directions in relation to the dots. And if we look, for instance, for the voltages, one voltage is referenced positive at a dotted terminal and the other one is referenced positive at the undotted terminal. So that says that V1 over 4 is going to be minus V2 over 1, or V2 is equal to minus V1 over 4. And for the currents, we have both currents defined as entering the dots. Then what we'll have is 4I1 is equal to minus 1 times I2. And so there's our relationship. Now, we need to find the voltage V0. What we're going to do is we're going to reflect all these elements through the ideal transformer and eliminate that, and then we'll do the analysis on this side of the ideal transformer. So let's look, for instance, at this expression. If I have a voltage over here, I'm going to have V2 on this side be minus V1 over 4. Well, if we look at our voltage source up here, that's 100 at an angle of 0. So if we take that 100 at an angle of 0 and multiply it by minus 1/4, we'll get minus 25 at an angle of 0, and we'd have a source polarized like that. Now, we could turn this over, change the polarity, and write it as 25 at an angle of 0 with that polarity. Now, the impedances just reflect by the turns ratio squared. Okay, so that's easy. It doesn't make any difference about the dot arrangement when we reflect the impedances through the transformer. So if we go through and reflect the impedances, we're going to divide them by 16. Okay, so we're going to be dividing the impedances by 16. When we get everything reflected through the transformer, here's our resulting circuit. Here's our source. Notice that we've changed the polarity. Here's with our 32 ohm. Here was at J16 at minus J24. And now we really have a single loop circuit. We can define a current I. Okay, and then just applying KVL, we'll have 2I plus J1 times I plus 3I plus J2 times I plus 20 at an angle of minus 20 minus J 1.5 times I plus 25 at an angle of 0 is equal to 0. Rearranging, this becomes 5 plus J 1.5 times I is equal to minus 25 at an angle of 0 minus 20 at an angle of minus 20. And if we solve that for I is minus 7.659 plus J 3.666. And if we look at our circuit, V0 is J2 times I plus 20 at an angle of minus 20, and that's 24.95 at an angle of minus 62.65 degrees.